Okay, welcome to the last panel of the day. But this is also the panel after we've talked about everything that AI could do. This is the panel that's actually going to discuss how to put all the assets in place to actually allow that to happen. And I think in my mind, sort of one of the most important conversations that can be had in the context of AI and where we're going. My two guests need very little in the way of introductions, but they have been at the forefront of AI and the development of AI in two different respects. Dilg with OpenAI, an architect of Stargate, really thinking about infrastructure and AI and how those two things have come together, have been kind of where you've been for the past several years. Senator Lee, your role in the Senate at the Energy Committee, you've sort of been the beacon in the Senate saying, this is an issue. We've got to deal with sort of the assets in order to make all these things happen. We've got to be talking about energy. We've got to be talking about how we enable these, I think, the dreams and goals that we have in mind for AI to really come to reality. And so you've been a tremendous voice for that. Just to jump right in, sort of first principles, what are the 2 or 3 words each of you would use to describe where the U.S. stands today in terms of building out AI infrastructure?
What comes to mind for me is actually a hurdles race, which maybe is helpful for you to think about in this point of the afternoon. But I do think the United States absolutely sprinting. We lead in innovation, we lead in frontier models, but we have a number of obstacles in front of us that we can see and identify now, and that I think we'll talk about here, and of which I think energy is really the most central. So that is really what I think of as we are out at a sprint, but we do have some very clear obstacles that we have to get through in order to compete.
First words that come to mind are the inputs, the outputs, and the machine needed to produce the outputs. Let me explain what I mean. When we talk about AI, there are 2 principal things that we need in order to build the machine. The machine, of course, consists of the data centers that you need to run all of this. Our ability to build those depend on our access to a couple of things. Chips. We're doing pretty well in terms of chip production, our access to them. The market deficit of chip production a few years ago seems to be working itself out well. But the other one is energy, electric power. Not just any kilowatt hours, but kilowatt hours that are base load, that are what they call firm power, reliable, consistent energy. If we can get a handle on that, with our ability to produce chips, we'll be able to build a machine. And with that, we'll be able to produce a lot of output. Now, what we can do with AI, we've heard a lot about today. But our aperture on that, our ability to accomplish things with AI, what we're able to do, how far it's able to extend, I think will ultimately be determined by what we can do to build the machine with those inputs. Because we'll be closing the aperture. If we don't have enough electric power to do this, we won't be able to run as many data centers, and our ability to do all this stuff will be somewhat limited. Whereas the sky's the limit if we can close the energy gap. Because between the LLMs, AI-assisted manufacturing, militarized drone swarms, I mean, you name it, there are all kinds of things we can do. But all those will be limited unless we can get the energy component right. So our job, my job in particular as chairman of the Energy and Natural Resources Committee, is to make sure that we get rid of as many of the artificial barriers imposed by government as possible, and we streamline processes because we've got a lot to cover. One final point on this energy thing. Remember, this is a binary outcome. This is a binary race. It's going to be us or China. One will win the race, and the winner will capture a lot of spoils to the detriment of the other. China right now is producing about 9.1 terawatts of electric power a year. And they're escalating, they're growing at a rate of about 7% annually. Whereas we're a little over 4 trillion per year, escalating at only 2% annually. We've got a lot of catch up that's got to be done over the next 5 years. And if we miss that 5-year window, it will be too late. And we will leave a lot of money and a lot of opportunity on the table.
So earlier panel, Chris Lehane sort of described this as like a transformative moment in technology. I completely agree. And from a historic standpoint, this is not the first time the U.S. has had some type of transformative technology that's come along. Certainly, railroads were a transformative technology. The interstate system was a transformative technology. The internet itself, transformative technology that came into being through some type of partnership between the private sector the government. When you think about the assets that are needed, and assets being, grid, workforce, maybe compute power, the people power that are required on a continuum that is sort of public good versus private investment, how do you think about assets along that continuum that are needed?
Especially when we compare it to other disruptive technologies over the last century or so, century to century and a half, yet in railroads, where Americans have pioneered in the disruptive technology in question. Every time we've done it, we've gotten there first. We have reaped substantial spoils as a result that have benefited us for generations moving forward. So railroads, I would add to what you added, broadcast television, radio, and then television. I would also add aviation. The entire world flies on regulatory standards and even the language that we use here in the United States because we were first in flight. So we were able to set the standards for that. And that's part of why we have to win this race. Now, in each of those circumstances, we couldn't have gotten there without innovation, without playing it the American way. I've long feared what happens if we try to compete against China at the way China plays. China has a centralized, a command control type of an economy. We will never be able to play the same way that they will. And I think here we have to do everything we can to maximize innovation in a way that you can achieve only through the private sector. It doesn't mean government doesn't have a role, but when we look at investment, I think one of the most tragic mistakes we could make in this, the more government is involved as a market participant, as an investor in the capital infrastructure, I think it dramatically increases the risk that the innovation won't occur and that we'll be mired in inefficiencies. And if you'll pardon the analogy, look at the Wright brothers. The era in which the American people as a whole were trying desperately to develop the first flying machines. The U.S. government spent $400,000, the present day equivalent of many millions of dollars, that they funneled through the Smithsonian Institution trying to build a flying machine. It failed at every single step. Meanwhile, it was a couple of tinkerers who owned a bicycle shop who used their own spare time and spare change to build something, and it actually worked. I think that needs to be the model that we have here, with the understanding that there are things that government does need to do along the way to remove barriers government itself has erected. But I'd rather see the government playing that role than having the government be the owner, the investor. The public-private partnership model, I think, could be disastrous here if we do this. This needs to be private capital because private capital innovates. Public sector funding has the opposite effect.
To pick up on that, I do think we're seeing that private capital is actually moving into the infrastructure space, and it's doing so in a way that is reducing risk for all of us, in the sense that many of you are involved in many different kinds of structured deals. We're seeing, deal after deal after deal. Chris spoke to many of them earlier that are coming out, but we are seeing the investment from the private sector coming in at different risk profiles. We've seen GPU-backed loans. We're seeing new innovative vehicles that mean that the capital is there. And it's there at a scale which in the beginning, it looked like could require significant government intervention. But we are getting there. And I think that's one of the things that we do best. I particularly like, Senator Lee, when we look at the internet, when we look at national highways, when we look at railroads, in each of those areas, we had different forms of government intervention. One thing that is more critical here than ever is actually government potentially learning how to get out of the way. We have these layers and layers of regulatory apparatus built up over time, and many of them are actually interfering with the speed that we need to get the compute online to really compete with China, and particularly to get the energy that we need at the pace that we need right now. And I think that may be somewhat unique about this moment as compared to the other times.
Your work on Stargate, your time at OpenAI, gave a lot of thought to sort of the different assets that you've got to kind of all link together at the same time. There's a lot of conversations going on about energy. There's certainly conversations going on about chips and data centers. Are there areas in that, little pieces within that continuum that you think aren't being talked about enough?
Certainly in my personal capacity, but I am very interested in where AI can accelerate the very technologies that it needs. So we talk a lot about fission, we talk a lot about fusion, but if you look at those two forms of energy, fission has some real obstacles that AI is not necessarily going to solve. One of them is fuel supply, their policy needs, their supply chain needs. Fusion, actually, many of the barriers are actually within the scientific discovery, they are physics. And so AI's ability to actually accelerate fusion timelines when you really talk to people, it is there. Now, can we accelerate fusion timelines enough to pull the technology forward into the time frame we need, which is really now to 2030? Probably not, which brings us back to natural gas and supply chains and the conversations we need to be having now. But I am optimistic in that space. Also, potentially materials discovery for storage systems. There are spaces where we need to be serious about what we can do with AI to actually accelerate and support AI.
Senator, are you seeing pieces that you kind of, as you again think about this broader picture, that you're more worried about beyond just energy creation, that you're more worried about, that we need to kind of make sure get the right amount of focus as well?
All of my biggest concerns that relate to our AI arms race against China, and I do see it that way. I do see it as almost a binary, not quite a zero-sum race with them, but it kind of is. Almost all of my biggest concerns there are with, obviously there are policy concerns about how it's used, and we'll have to look at that moving forward, but that's not really the focus of this conversation. Yeah, they are all related to energy because we have innovators here, we've got technology, we've got the talent here, we've got chips, everything else is in place. Energy, this is a really tough one. You do have to have baseload power. You can't really build new coal-fired power capacity in this country. The best we can do is prolong existing coal-fired power plants. That doesn't really increase to where we need to be. And so the next leap is usually nuclear. And I love nuclear. There's a lot of hope in that, especially if we can get to the point of fusion. It'd be fantastic. But there's a lot of talk about small modular reactors, micro reactors, and sort of updates to the AP1000, more traditional large-scale nuclear power generating thing. But all that stuff takes time. Best case scenario, even if we do everything streamlined through the Nuclear Regulatory Commission, we end up with sort of some cookie cutter designs that can be deployed. We're at least 10 years away from that, where that stuff can be deployed on the scale that we need it. So what does that leave? Now, the next logical step would be, okay, well, more wind and solar. You can deploy that stuff faster, in many ways per kilowatt hour, more cheaply. 18 to 24 months is the norm. If you want to deploy, 500 megawatts to 500 to 1,000 megawatts, you can do it fairly quickly and fairly cheaply. The problem is it's not baseload power. We don't have storage technology that allows us to replicate baseload power with that. So that's not going to work. So what do we do? 10 years away from nuclear, that puts a lot more pressure on natural gas. Natural gas, we've got supply chain issues, most notably the fact that we've got two principal manufacturers of gas turbines in this country. GE Vernova is one, and the other is Siemens. Both of them have a 5 to 6 year backlog on new gas turbines used for electric power generation. So we're looking at ways to expedite that process right now, seeing if we can open up the market to other competitors in other parts of the world. Hopefully through 3D printing and other technologies that they're experimenting with here, we can accelerate that. The only other sources are things that are going to be helpful in some areas. Geothermal, for example, I'm working with my Democratic counterpart on the Energy and Natural Resources Committee, Martin Heinrich, on a geothermal bill. Geothermal it produces emission-free baseload power. It's just not available everywhere. The upside is we have new technologies up now through horizontal drilling. We're able to get to a lot more hotspots, but it's not available everywhere. So gas really is going to be our bridge fuel to get us there. We really have the next 5 years. We got to put the pedal to the metal on that one, and we're going to have to be creative with how we handle NEPA and all the other regulatory hurdles. So these regulatory hurdles are set up. You understand the purpose of a system by what it does. Our regulatory system is really good at doing one thing, which is delay. In a permission-based society where somebody needs permission to innovate before they may innovate, you will be killing innovation unless you figure out a way around it. There are some creative ways around the NEPA delays and the other regulatory delays that we're working on every day.
One of the earlier panels took a look at, earlier was inspiring, I think, Casey Mulligan, your slide with looking at different small businesses, and you really got a sense of how AI can transform sort of different individual small businesses. But on the generation side, in terms of solving the infrastructure problem, we start to get into questions of scale, right? And certainly Stargate is a $500 billion project. The news between NVIDIA and OpenAI is $100 billion investment. Now, look, I work at a slightly large private capital firm. Even I know that those are not things, that's not change that I find on my couch anywhere. So if you can't find that capital from like a crowdsourcing perspective, should we have any concerns about the need for that capital concentrate power in just a few entities that are out there? Is that a concern that should be out there? If so, yes, or if not, why not?
Yes, that is a concern. Anytime you're looking at the concentration of power, whether it's political power or whether it's economic power, there are concerns associated with the excessive accumulation of power in the hands of the few. That is all the more reason, though, to be awfully cautious about getting government in the position of being the provider of that capital. Because when government does that, it tends to even further consolidate market power. There are fewer market participants, less ability to enter the field. We end up creating de facto berms, walls, moats around industries. We wall off large market incumbents from competition, and competition accelerates and enhances quality and tends to bring down price. So I think that's the best way to do it, is to ensure competition. But yeah, obviously that's a concern. But the more we can diminish the risk associated with the lengthy delay. The delays are fine insofar as they're enhancing the safety, the health, the welfare of the American people through the environmental standards that we've got. But there are a lot of environmental laws like NEPA that can do, and in many countries that have followed laws like NEPA, are doing the same amount of environmental good, but without the indefinite, open-ended litigation risk, where through a combination of the Equal Access to Justice Act formulas that we use to compensate the environmental lawyers who bring suit under this, often paying them at above market rates, we are artificially incentivizing them to run out the clock. That delay does no good to anyone other than Beijing. So we got to find ways around that, because otherwise we will be faced with a delay. And that 5 years, it's not 5 years we can make up later if we lose this race.
To your original question, we've been talking here a lot about the pain point, because I do think bringing more energy online truly is the pain point, and particularly connecting more energy to the grid. And there are so many policy challenges in actually moving the country to where we need to be. It is also true that you saw the announcement from OpenAI that was with Oracle and SoftBank with respect to the Stargate project, announcing, I believe it's 5 new sites and 7 gigawatts. I want to be sure I don't have those backwards, but I believe it's 5 new sites, 7 new gigawatts. Those are actual sites. So they have announced where those sites are. So you will also see the private sector being opportunistic. There is power out there, and obviously not going to reveal any internal information except that I was one of the people who was hunting for it. It does exist, and the companies are finding it, and they're working very hard to find it. So while the policy conversation needs to be ongoing, there is still reason for optimism that these pieces come together even as we solve some of these problems going forward. I think what the solutions are is deeply, deeply debated in DC and is extremely challenging. Should we be looking at, co-located power? Should we be looking at grid-connected power? Where should the sites be to ensure that electricity will remain affordable for everyday use is something that the companies are looking very carefully at, but also regulators and policymakers across the country. And then you also see that there are companies, and Google in particular has been very focused on this, really trying to pull forward some of these technologies through a combination of financial mechanisms, PPAs and the like, as well as all of the companies, I think, invested in accelerating the very technologies that could help. There are also projects, for example, using AI to try to help PJM get through some of its interconnection woes, to bring online some of the natural gas that we know exists in Pennsylvania, but have had more trouble accessing than in places like Texas. So all of these interrelated, but I do think even as we're debating the topics, even as we're trying to move through the hard problems, you are seeing the companies press go, go, go. And I think you will continue to see that from the private sector, facilitated by the government.
To take a brief moment for a slightly more fun question. Great career, OpenAI, the Department of Energy, an accomplished lawyer, but you're also the city manager for the city of Santa Monica. What would that have meant for you in that role when you think about how localized the benefits can be?
Yes, it's funny for those of you who are younger, careers are funny, who knew that local land use law would become so important to my future in infrastructure. When I was the city manager in Santa Monica, I did have one key moment in 2021 when the pandemic had waned a bit. And I was reading a National Intelligence Council report that was looking at the biggest challenges we would face between now and 2040. This was not necessarily focused on the AI conversation, but it pointed out that the scale and scope of challenges we would face, geopolitical, economic, weather, and climate, would be more massive than we had seen or experienced before, that our democratic systems would struggle to solve problems at pace, and that the public consternation that would result would actually be one of our most significant threats. And I think that, to me, coming out of the pandemic, made so much sense when I look at the fires in California now and many of these other issues. I am an AI optimist because I believe our challenges are immense and that this is a problem-solving technology. And so what we are working to do is to solve problems together, ultimately to help us turn to new and many more problems.
To turn to many more problems.
Sorry, to solve many.
Yes.
To accelerate the solving of the problems that we face.
10 years from now, if we were to look back, what is one or two things that we will look back and say, I wish we had done that in September of 2025?
The answer to that can be summarized in 2 words. It depends. It depends on a few things. It depends on, first, whether we've won. If we win that race, and I do think that there will be a moment when there will be an objectively verifiable answer of whether we've won. If we've won, then we'll probably look back and say, well, we could have done this or that better, but it all worked out in the end. If we have lost by then, it won't matter that much what we could have done because we won't be able to undo that. But the biggest thing that if we have lost that I think we could look back and say, had we done it this way, things would have turned out better, is just deregulate. We have to remember how many of our laws, just the sheer volume of our laws, are unprecedented, not only in the United States of America, but in any free civilization that has ever existed on planet Earth. Let me just give you a brief example of this. If you ever come to my office sometime in Washington, I'd love to see any of you stop by. I'm in room 361 of the Senate Hard Office Building, and I keep these 2 stacks of documents in my office to demonstrate to people some of the problems with our laws. I have a short stack and a tall stack of documents. The short stack is a few inches tall. It is usually a few thousand pages long, sometimes as short as a few hundred pages, but it consists of the laws passed by Congress in the previous year, usually about that thick. The other stack is 100,000 pages long. In a typical year, it's about 13 feet tall, and I've got it organized in 3 separate bookcases. It's last year's Federal Register. For those of you blessed enough not to know what that means, I envy you deeply, I do. It's the annual cumulative index of new federal regulations as they're first released for notice and comment and then later finalized. It's the administrative deep state's way of saying, citizens, prepare to be governed. I'm going to pretend that this is a democratic process so you can give notice and comment, and then you'll be stuck with whatever we decide anyway. The problem with it is that we're talking about 100,000 pages of new law every year. Now, these are not hortatory. These are not advisory. These things will put you in prison, shut down your business, result in $1 million of fines, or all of the above if you don't comply with every word. And yet not one of those words was ever enacted by Congress. My copy of Article 1, Section 7 of the Constitution says you cannot make a federal law but by Congress, and you cannot make a federal law in Congress unless you follow the formula of bicameral passage followed by presentment to the president. So I think that's what we will look back on and wish we had gotten better. I think we've been operating outside the constitutional structure for a long time in ways that, for reasons that escape and astound me, the Supreme Court of the United States has been unwilling to enforce. The Supreme Court acknowledges that this is unconstitutional on some level through the so-called non-delegation doctrine. The problem is they've defined it in such a way that they've made it impossible to enforce. I do think that's about to change. Academic writing in this area and some nascent jurisprudence suggest that the Supreme Court is about to realize that their non-delegation doctrine has been diluted to the point that it means nothing. And then there's an entirely different angle jurisprudentially under the separate line of cases culminating in INS v. Chadha, decided about 40 years ago, that makes what we're doing unconstitutional. The reason I raise all this, we've got to get away from the crack cocaine and the inhibitor that is the modern administrative lawmaking state. When most of your laws measured by weight, volume, regulatory compliance costs, economic impact, you name it, are written by unelected, unaccountable bureaucrats, people who will never stand for election, you've got a problem. Especially when it's those same regs that are resulting in 5 to 10 years in many cases. In other cases, it can be decades of delay for a single public works project. That's what we're facing. That's what we will most wish we could do over again if we get to 2030 and we have lost. So we better do it now.
Got to end on a positive note. Be a little half
I thought
full.
that was positive.
Going into drinks and dinner. Senator, one thing about sort of the promise of AI that you kind of, that's amazing in your mind. Like, what is it? What is one thing that you think about like that? This is going to be a remarkable transformation for our world.
And recorded human history is what, 4,000 or 5,000 years long. For the entirety of that period of time, most people could only dream about just some of the most basic things that AI could open up for us, about the ability to have more of your time set aside that you can spend with family, for leisure, for education, doing what you want. Artificial intelligence will allow us to live longer, happier, healthier lives, more productive lives, hopefully pursuing more lofty objectives. Everything we do can be made stronger, smarter, faster, and with less conflict if we're able to win this. Something as simple as writing a speech or preparing a research memorandum, or as complex as building a large cargo ship or military vessel. All of these things will be expedited by AI. Are there scary things that can happen with it too? You bet. Just like there have been with aviation, aerospace, computers, and everything else. And yet the arc of history has tended to enhance the quality of human life with the development of those technologies. But those technologies, as beneficial as they've been to us, as a drop in the bucket compared to what AI can do for the human condition. And I, for one, look forward to it.
Acceleration of scientific discovery underpinning much of what was just stated. I think to be able to move science faster will put in our hands abundant, affordable energy and other, as I mentioned, solutions to really humanity scale problems.
Can you all thank me for these two amazing panelists?